Righto, General Maths students. In this video we're going to study inflation. There's a bit of a description here about what that means. You might want to pause the video and have a read of this, but basically it just describes how the costs of, or the price of things goes up over time. So things cost more as time goes on. You might have heard stories from older people that you know several years ago, what they used to cost, and it's generally lower. I myself remember vaguely paying maybe 70 or 75 cents for a can of soft drink from the shop, whereas now it could be $2.50 or $3 and on the way up, getting more all the time. Now this isn't exclusively true, you know, there are times when the cost of things goes down, there are fluctuations in that, but in general over time things do go up in price. Now, the formula that we use is the same as for a compound interest formula. That's how it works, just like compound interest, in that the current price of something, of something that you're buying, will go up at some stage, and then it'll go up on top of that the next time there's a price increase. So it works like compounding interest in that way. And generally, we might not find that the costs of things like everything goes up each year necessarily, but in general, most of the questions that we deal with, there is a yearly increase in the price of whatever it is we're dealing with, and that's not uncommon for a business maybe to increase their prices of something each year, but that's generally not always the case. Sometimes we see questions in this course that involve daily inflation. You know, there are extreme cases that have happened throughout history where inflation's very high and things can go up in price on a daily basis or even an hourly basis, not just on a yearly basis. But the examples we're dealing with in this video will all be involving a yearly increase. This one here, we'll have a go at this, the surfboard. We're predicting the cost or price of a surfboard in 6 years' time. Right now it costs $520, and inflation is going to be at a rate of 5% per annum. Now, having done some compound interest questions in previous videos, you might want to pause the video now and see if you can work this one out before I do it. So I'll give you that opportunity now. Okay, I'm going to have a go at it now. So we're just using the compound interest formula as above. All right, so the future value is equal to, okay, so the present value, PV, is what the surfboard costs now, $520. 1 plus, okay, and the inflation rate is 5%, so of course we need to convert that to a decimal by dividing by 100, which gives us 0.05%. And this is for 6 years, that is our N value, which goes up here. Now, one good thing about the inflation questions, because they're generally yearly, we don't need to adjust the interest rate and the number of periods the way we do with compounding interest by dividing or multiplying appropriately. So we can just leave those as is. Okay, so you pop that into the calculator and we'll see what we get. So this surfboard is going to cost $696.85 in 6 years' time. What did we get there? $696.85. Okay. Righto. So the next example, which I have here, is one where we're going to need to do a bit of rearranging of the formula, because we're looking at the cost of a television now, and we want to make a calculation to see what was it worth 4 years ago, or how much would it have cost 4 years ago. So it was, if you can purchase it today for $1,200, what would it have cost 4 years ago. Righto, so we're going to take the formula FV equals PV by 1 plus I to the n, and we want to make the present value the subject. You've seen a video on this before, so I won't dwell on it for too long, but we know that when we rearrange this, we divide by what's in the brackets, and we want to make the present value the subject of the equation. So that is what we're going to get. Righto, you maybe want to pause the video now and have a go at this yourself, then I'll do it. Righto, I'm going to proceed. So we've got the final value of 1,200, which goes on top there. And then we've got 1 plus 0.06 to the power of 4. So when we put this one into the calculator, we'll use that fraction button there, 1,200 over 1 plus 0.06 to the power of 4. So $950.51. TVs are probably not a really good example here. I'm finding when I look at the costs of electrical goods, they're tending to get much more affordable as time goes on. But anyway, that's how we do this example here. Righto, now, this last one is a common type of question in our course about an investment. Now, there's a description here that you might want to pause the video and have a read of this about how we need to make sure that any of our investments give a greater rate of return in terms of the rate of return being the percentage increase than inflation. So if like it's explaining here that if inflation is at 8%, then we need to basically make sure that our investment returns at better than 8% in order for our money to gain value. It's saying here that this person, the investor's capital is increasing at 8%, the investor is making no gain at all. But having said that, if the investor didn't invest in anything and just got 0% on their money, then that's worse than at least getting 8%. At least when they're getting 8%, they're keeping up with inflation, so their money is not losing value overall. But typically what we want is to check that rate of return and make sure that it's better than better than inflation rather. All right, so we're going to treat this in a couple of different ways, this question. And the first way is to actually calculate the rate of interest. And I'm going to use the finance section of the calculator to do that. So just open up a new document and get a new calculator there. All right, and menu finance and go to the finance solver, number 1. So this one here. Righto, so I'll go back to our page here and I'll detail the inputs. Whenever we use the finance solver to do a question, we need to detail our inputs. What are all the different values that we're going to write in? So we've got the number of periods, we've got the rate of return. That's actually what we're trying to find, so I'll put a bit of a question mark there now. Okay, so we've got our present value, and all these different inputs that come up on the calculator screen. Sorry guys, my computer's just a little bit laggy at the moment. I'll just take my time and let him catch up. Okay. Righto. So, all the different things we're going to put in. So let's just have a quick look at this question here. We've got Will, who's purchased an antique clock for $3,000 and then 4 years later sells it for $3,600. Comment on Will's investment given that the annual rate of inflation was 5.5%. So what we're going to do is we're going to calculate the interest or the return that he got. What rate of interest is required for $3,000 to grow to $3,600? And we don't need to solve this algebraically in this course. We're not expected to, so we're going to use the calculator to do it. All right? Okay, so these are the inputs. So the number of periods, we've got 4 periods because it goes for 4 years. The rate of interest, is what we're going to be calculating. The present value, well, Will spent $3,000 on this clock. So that's what the original or the present value of the clock was. And of course, when we're talking about money going into the bank or being spent on something, that's money out of pocket. So we put a negative there. Oops. Okay. There's no regular payment here, so we'll just put a 0 there. Now, when Will sells the clock, he gets that money back. So this is going to be a positive $3,600. That comes back into his pocket. And this, because it's an inflation with a yearly rate, we're just compounding it once each year. So we can just put 1s for PPY and CPY. So let's go ahead and put those inputs here. So 4 years. I'll leave this one blank because we're trying to find the I value. The present value is negative 3,000. And then the final value, 3,600. And those are all as is. We can leave those. So I'll go back around. I'll go down tab to the percentage rate and push enter. And we're getting 4.66%. Okay, so let's go back and have a look at this. So I'll just make a note. We'll go ahead and write that down. This is 4.66%. Right, now that is lower than 5.5%. So this is not a good investment. All right, so we'll make we'll write a sentence. Yeah, so not a good investment. Because the rate of return is lower than the rate of inflation. Sorry guys, I'm having to go slow here. The computer's just a bit laggy. Lower than the rate of inflation. So really, you know, we'll be losing money in real terms overall. All right, now the other way I want to treat this very quickly is to actually do a compound interest calculation to see how much money Will need to, well, how much would this $3,000 here that Will has at the beginning, how much would that need to grow to in order to keep up with inflation? All right, so a very simple calculation using the compound interest formula just to get the final value really. So the final value equals, okay, so I'm going to put that 3,000 in as a present value, and at 5%, so 0.055 to the power of 4. So if this grows at 5% for 4 years, all right, this calculation will tell us how much money would need to be returned at the end in order to keep up with inflation. So let's have a go. 3,000 bracket 1 plus 0.055 to to the power of 4. And so Will would actually need this to grow to $3,716.47 just to keep up with inflation. So given that he's only getting $3,600 back, this is not a good investment overall. Righto, so go ahead and try some inflation questions. They tend to be reasonably manageable. Just got to watch out for the ones that are asking you to comment on an investment. Find the rate of return and compare it to CPI, or you could use a compound interest calculation to determine whether or not it's a good investment.